Hey, welcome back. Let me ask you something. If you walk at a constant speed, let's say your speed is constant 1 meter per second, and you walk for 4 seconds, how can we figure out the total distance you've traveled? That question leads us directly to integrals. We can represent this with a graph. Time on the horizontal axis, speed on the vertical axis. This graph forms a rectangle. Its width is 4 seconds. Its height is 1 meter per second. Now here's the key idea. The area of this rectangle shows the total distance traveled. Then, as we know, distance equals speed times time. But what if I told you there's another way to think about this? Let's start simple. Instead of looking at the whole rectangle at once, let's split it into 2 equal parts. Each part still has an area, and if we add those 2 areas together, we get the same total distance. Now let's go a step further. What if we divide the rectangle into 4 equal parts? Each piece gets smaller, but when we add all 4 areas together, the total distance is still the same. So here's the pattern. Now imagine taking this idea even further. What if we keep dividing the rectangle into more and more pieces, until those pieces become incredibly small? Each slice is a very narrow rectangle. The height is still 1 meter per second. But the width is now extremely small, so small that we give it a name. We call that tiny width, dt. The area of each rectangle represents a tiny amount of distance. Now here's the powerful idea. If we add up the areas of all these thin rectangles, not just a few, but infinitely many of them, we capture the total distance exactly. This process of adding up infinitely many tiny areas, each with width of dt, is what we call an integral of dt. But there's one more important question. When we say we're adding up all these tiny areas, where do we start? And where do we stop? In this situation, we start counting distance at the moment you begin walking. That's time 0. And we stop after 4 seconds. That time interval from the start to the finish. It tells us exactly which part of the graph we are adding up. We're not adding everything forever. We're only adding what happens during this specific time window. Now it's your turn. If you walk at a constant speed, let's say your speed is constant 15 meter per second, and you walk for 20 seconds, how can we figure out the total distance you've traveled? Don't worry about solving the integral just yet. Right now, the goal is simply to understand how to write it. We'll learn how to work through the math step by step later on. Pause the video and try to solve this equation on your own. Take your time and really think about each step. When you're done, you can check the final answer in the description. If this helped you understand the idea, go ahead and hit the like button. And if you want more clear mathematics explanations like this, make sure to subscribe. Thanks for watching, and I'll see you next time.